In place of the lab 2 described in the lecture, I want you to do this hands-on activity for lab 2. To begin the work on lab 2, download the lab 2 worksheet. You can see part of it here, and read it completely. Answer the first 5 questions before doing the lab activity. Now make sure that you understand all these questions. We actually discussed all this in the lecture. In the lab, we will allow a car to move through a distance x. Now here I have the table, and measure the time t, the time taken for the car to travel the distance x. Then calculate the speed as distance divided by the time. Now we will repeat the procedure for 9 different x values, and each time we measure the time, that means you will have 9 different speed values. Then calculate the average speed and record it here. Now make sure that you use the correct unit for the average speed. You will lose 1 point for not using the correct unit. Now that we have 9 sets of distance and time values, you need to draw a graph with distance on the y-axis and the time on the x-axis. Now measure the slope of the graph. If you haven't watched the graphing video, you should watch that before you do this activity. Now measure the slope of the graph and show on the graph how the slope is measured, like I have demonstrated in the graphing video. Choose your delta x and record it here with units. Choose your delta t and record it here with units. And calculate the slope as delta x over delta t, and write the slope with the correct units. Now remember, the slope has a physical meaning. If you do not use the correct unit, that physical meaning is lost. Alright, let's now go and do the lab activity. Now here I am going to run the car through a certain distance x. You can measure that distance x here, and the time can be read on the clock. Alright, let's do the first trial. I'm going to start the car. I'm going to stop it. This is the first trial. Measure the x and t values. I'm going to reset it. Let's go for the second trial. Stop. The x and t values for the second trial. Let's reset it. Start the third trial. There you go. You got the x and t values for the third trial. Let's reset it. Start the fourth trial. There you go. Measure the x and t values for the fourth trial. Let's reset it and go for the fifth trial. All right, measure your values now. Reset it. Let's go for the sixth trial. Alright, take your measurements now, reset it. Let's go for the 7th trial. Stop it. Take your measurements, reset it. Let's go for the 8th trial. Take your measurements now. Reset it. The last trial. Alright, you have 9 sets of measurements. Find the speed each time, measure the average speed, then, I repeat, do a graph of x on the vertical axis, time t on the horizontal axis, and show how the slope is measured. Your graph will probably look like this, and you need to show how delta x is marked, delta t is marked, how the slope is measured of the graph. Now complete the lab worksheet and upload it on in the lab 2 page. Lab 3 to measure acceleration was discussed in the lecture, and I hope you have completed that and submitted already. This is Lab 3A, another simple way to measure acceleration, using the animation we used for Lab 2. If a car starts from rest, what does that mean? Starts from rest, its initial velocity is 0, and accelerates for a time t, the velocity it will acquire at the end of that time is given by v equal to at. Now look at the similarity between this equation and y equal to mx. So if you draw a graph of v on the vertical axis and t on the horizontal axis, what will be its slope? Its slope will be a, the acceleration. Alright, what is the unit for measuring acceleration? Do you remember? Well, I want you to write down that in the lab report. Well, in the lab activity, we will run the car for a time t and measure the velocity at the end of that time. Now, you will record those for trial 1. You record the velocity at the end of time t. Now, this should read time t in seconds. Alright? And we will do several trials. We will run the car for different time periods so that v and t will be different. And what will you do? You draw a graph of v on the vertical axis and time t on the horizontal axis and measure its slope and show on the graph how the slope is measured. And also, what does the slope represent? As I said in the last class, if you do not include the unit for the slope, the physical meaning of the slope is lost. Alright, let's go and look at the animation and take our measurements. I will run the car for a period of time t. You measure the velocity. You see where the velocity is going to be measured. measure the velocity and the time shown by the clock. All right, first trial, let's start. I'm going to stop it. Take the velocity value and the time value. All right, I'm going to reset it. Second trial. There you go. Measure the velocity and the time. I'm going to reset it. Let's do the third trial. There you go. Measure the velocity and the time. I'm going to reset it. Let's go for the fourth trial. All right, measure the velocity and time and record them. Let's reset it. We'll go for the fifth trial. All right, measure the velocity and time. Let's reset it. Let's go for the next trial. Is that the sixth one? Let's start it. All right. You got the velocity and time, and we are only doing one more trial. All right, reset it. Start for the last trial. Measure the velocity and time and record it. Well, we have, I think, 7 trials. So use those velocity and time values to do a graph of velocity on the vertical axis, time on the horizontal axis. Show how the slope of the graph is measured. Now remember, you need to do the trend line before measuring the slope. Show how the slope is measured and record it with the appropriate unit. All right, complete the worksheet and upload it.